All right. Hello, everyone. Welcome to week 4, Reverse Engineering 1. My name is Richard.
I'm Pete.
And we'll be covering reverse engineering. All right. Let's get started. Where's my mouse? All right. So first of all, some announcements. Fall CTF is this weekend, this Saturday in the SIF, 12 to 6 p.m. Bring your friends. There will be pizza, lots of fun challenges, and there will be no meeting this Sunday because Fall CTF is on Saturday.
Need sleep.
Yes, we all need sleep. So here is the meeting flag for today. Go to ctf.sigpwny.com. Enter this in for Reverse Engineering 1. Give you guys a second. Yeah, these are some quality memes right here. The right one is about pointers.
Can you explain why it's NSA backwards?
You can explain. I'm actually not quite
So Ghidra used to be closed source software made by the NSA. They made it public, so now everyone can use NSA software for free. It's great.
I'm pretty sure they didn't put in a backdoor, but who knows? Right. Sorry. Okay. So brief table of contents of today. We're going to talk about first a little bit about what is reverse engineering, and then we're going to do 2 demos, one with Ghidra and one with GDB. So right now, as we're talking, it might be a good idea to make sure you have Ghidra installed as well as GDB. It should work under WSL. So hopefully you guys all have that set up by now. So what is reverse engineering? In short, it's figuring out how a program works and trying to mess with it by, for example, writing keygens for password checkers or finding secrets in the program. Sometimes they're just hidden constants, or other times you might want to find bugs in the code. These are all goals of reverse engineering. Specifically for the challenges that we're going to do today, they're usually you want to find some sort of flag, and that's best done by understanding the code. Now, there's many different languages, and each one comes with different strategies for how you want to reverse it. Today, we're going to mostly focus on C and C++ binaries on Linux, and they're called ELF binaries. Yeah. Okay. So first, some overview of the compilation process. So how do we get to a binary from C code? Well, the compiler, which might be Claim, might be GCC, takes your source code and then turns it into an executable. It parses the source code and optimizes it, and then generates the executable, which contains machine code that your computer can then run. So your computer cannot read the original C or C++ source code because that's in a text format. It's designed for you to program in. What your computer interprets is the machine code, which is usually displayed through assembly. Okay. So the executable, again, the processor understands machine code, not C code. So that's why we need to mess with it. And there's different parts of an executable that interacts with the registers in the stack. So the register, there are several registers on the x86 system, and each one stores a 64-bit number. And those can also be addresses that get dereferenced. And then there's also a stack as well as a heap. If you don't understand what these words are, don't worry. They'll make a lot more sense later on once we actually get to the GDB demo as well as the Ghidra demo, where we show you how these systems interact, or how these parts interact. But in short, stack is usually stores function local variables, and as well as a call tree. So every time you call a function, it pushes the return address onto the stack. And then heap is for bigger memory segments, as well as like dynamic memory allocation. And these are concepts that are going to come up again once we get to Pwn later on. Not today, though. What is the static? Sorry about that. So there's 2 main different types of analysis that we can do in order to reverse engineer a binary. One is static, and we usually do that through tools like Ghidra. And what we can do in Ghidra is decompile. So decompilation is a process of turning compiled assembly code back into the original C code. But it's not a perfect conversion because we lose a lot of information in the compilation process. So the decompiler has to try to guess what the original code is. So in terms of a debugging analogy, so static analysis is sort of like reading your source code, and dynamic analysis is like adding print statements. So with static analysis, you're just looking at the binary in various different ways. But with dynamic analysis, you're actually running it and seeing how it behaves under different inputs. And we do dynamic analysis through GDB, run the program, set breakpoints. Again, I'll demo a lot of this later on. Okay. So now Pete.
No.
I don't know where it's coming from.
Okay, sorry about the clicking, guys.
Yeah, sorry about that. Oh, I think it's a little bit better now. Oh. All right. Pete will now talk about a little bit about Ghidra.
Okay, yes. So as Richard mentioned, Ghidra is a method for statically analyzing programs. So this is a follow along demo. So if you guys haven't already, please open Ghidra, and I'm going to take you guys through the project. And I also want you guys to download the file debugger from our CTF. Oh, there's slides. Okay, sorry about that. Min's the only one that actually knows how this all works. Test.
Every connection.
Oh, that's true. I think it works. Or try disconnecting this guy.
Which mic is the mic? Oh my god.
Just touching it makes it go crazy.
Sorry for interrupting, guys. While you guys wait, go ahead to the ctf.sigpwny.com and download the debugger file. So it's just the challenge is called debugger, and you should be able to download a binary just by clicking on the challenge. And we'll need that for both the Ghidra demo and the GDB demo. So if you download that, you can walk along with us. Yeah.
What? Okay. Yeah. Okay. All right. That might be good enough. All right. Cool. So Ghidra, as we mentioned, is an open source disassembler or decompiler, and it's written by the NSA. And it's going to take a best guess at what the assembly compiles back into C code.
Yeah, also, the meme here is I'm sort of being sarcastic. You guys understand it.
Oh. Okay, so on the left here, I have a snippet of C, and on the right, I have a snippet of what that C compiles into. So as you can see, the assembly it compiles into is sort of hard to understand, and that's sort of the point of Ghidra, right? Ghidra is going to take the code on the right side and try to take its best guess at what the code on the left side is going to look like. Oh, God. Okay, right. So on the right, now we have what Ghidra guessed is the program. So as we can see, it didn't actually do a perfect job, right? It replaced our for loop with a do while loop. And that's because if you think about it, there's not really a great way for us to tell the difference between a do while loop and a for loop once it's been compiled into assembly. So for our purposes, we can say this is good enough, and we can still understand what the program is doing, even though it's slightly different constructs, right? We can still understand that this is some sort of looping condition, and we can understand that it's looping based on the variable I in less than n, and it will add up into our result. Okay, all right, now for the follow along. Okay.
This screen is on like the right side of this.
Can you just drag it over? Okay, so I want you guys to all go to File, New Project, and it's going to pop up with this window. You want to select Non-Shared Project and hit Next, and then you can place this anywhere you want. Yes. Raise your hand if you need more time to open Ghidra right now. I'll wait a couple minutes for that. Yes, and we have slides for downloading and installing Ghidra. Oh, it's okay. You can like maybe just look at how we do it and then follow along after the meeting. Yeah.
Yeah, this meeting will be recorded, so you guys want to screen share is down. Oh no, no fine. Screen sharing is on.
Just hit resume.
Is the share? Did you share only the? Did you share the full screen?
No, I just.
Why did you share the full screen? For what? So what?
All right, raise your hand if you still need another minute to get that open. All right, I'm going to wait another minute for those people to try to get Ghidra open. If not, I would encourage you guys to look at my demo as I do it and then do the steps after the meeting or on your own time. If you need someone to explicitly come and help you set it up, please raise your hand and we can have someone come and help you. All right, so let's get going. So I'm going to select my project directory. So I'm just going in Richard CTF directory, and I'm just going to name this one like Ghidra files. And we're going to hit finish. So now you should have a window that looks something a little like this. This is your project, and we're going to want to import our file into it. So you're going to want to go to File and Import File. And where did you download it to?
Okay, we can recover the second.
Oh, I saw it. All right, so it's going to pop up with this. We're going to accept all the defaults. It's telling us this is an x86 binary with a little endian, and it's 64-bit compiled with GCC. And then once we have this, we can double click on the file and it's going to open the disassembler. Sorry, it went to the other window. So you're going to want to double click on the file. And can you drag the analyzer? As well as this one. Okay, so it's going to pop up with a couple windows. The first one you'll probably see is this import results. We'll ignore that for now, and I want you guys to hit yes on the analyze window that pops up. And it's going to provide you with options. We're going to accept all the defaults and just hit analyze. You don't need to change anything on here. And I'm going to give you guys a second to catch up on that. So again, once you have your file, you're going to double click on it and it's going to open the disassembler. Once you've opened the disassembler window, you're going to click the yes to analyze, and that's going to prompt you, and then just hit yes and accept all the defaults. Press analyze, yeah. And once the window that pops up for that, you can just hit the bottom left, I believe, and just say go or start. You don't need to change any of the defaults. Oh, okay. Okay, so for people on Mac that are running into an issue, it might say decompiler is blocked from running. So what you're going to want to do is, I hate this system. you go to security and privacy and mark it as undefined. So you're going to want to go to settings, security and privacy. And it's going to pop up probably. I don't remember.
This is not
It's gatekeeper.
gatekeeper. So I like I found the file and I right clicked and opened. Like,
Oh,
yeah.
this is why we had a setup meeting.
Yeah. Maybe try Google.
You're saying right click on all of them?
Yes.
Go to compile. And then you have
Settings, go to settings,
okay, yeah.
go to security and privacy, and then click general. And it'll show up, click general, and it'll show up a little thing at the bottom.
Okay, yes. So sorry. Click general and security and privacy. It's going to pop up at the bottom here, and you just want to hit allow. And once you hit allow, you'll be able to rerun the decompilation. So if you want to rerun the decompilation, you can just do analysis, auto analyze, and it's going to pop up that window again, right? And we can just hit the blue analyze button. Oh, okay. Yeah, you can. You actually have to click that allow for every different architecture you do because there's a different binary for each type of decompilation.
You can also systematically remove the flags for gatekeeper.
Oh,
Every time you like download a song.
seems sus.
It's a little bit soft.
Do we have the shortcut somewhere?
We do, cheat sheet.
Whatever that is, you.
Wait, what are you trying to?
I just want to put it on the left side or something. Okay, whatever. We're just waiting.
Wait, here, we can present to, actually, no, that's still gonna full screen, yeah.
It's fine.
Just for this ring.
We'll go to the,
All right, I'm gonna wait about 2 more minutes and then I want to get going for everyone on Zoom. All right, so let's get going on this. I know some of you are still setting up your Ghidra. I would encourage you guys to maybe take a break on your Ghidra, follow along with the demo I'm doing, and then go back to setting up your Ghidra. So on the window here, we have our full Ghidra instance. I'll just full screen it so everyone can see. So on the left, we have the assembly, and on the right, we have where the C code is going to go. So on the left side, we'll see the symbol tree, and the most important folder here is functions, right? So the main function in C is going to be called main. So let's click on this, and we're going to see some pretty strange looking C code, right? This is its best guess at what the program looks like, and we're going to give it some hints about how the program works, and it might be able to do a better job, and we can understand this better. So just off the bat, we can see it gave the function signature as these parameters. Does anyone know the correct C main function signature and can tell me? Just raise your hand if you do. Yes. Yeah, so the return type is going to be int, and it's going to pass in the argument count, and then as well as the arguments. So we're going to right click on this, and we can hit actually edit function signature, right? And we're going to give it the correct return type, which is going to be int. And we can also retype this. This is going to be argc, and this is going to be a double pointer, and this is going to be argv. Right, so just based on that, we can see that it sets this variable to our argument count. And if the argument count is less than 2, it's giving us an error, right? It's saying, oh, you need to actually put in the flag for our thing. And if we look at the bottom of our program, we can see it returns this variable, local C. So I am going to right click on this and hit rename variable. And this is going to be our exit code. Another thing we can do is, this is just a copy of argv. We can see it just directly sets it. So you can try command plus. I'm not sure it works.
I don't. Let's not. I don't think there's a.
Sorry if you can't see.
Yeah. If you guys can't see, hop on Zoom and then you can zoom into the.
Yes. So as I was saying, the argv, we'll just rename this as argv sort of copy or something. So I'll just do C for copy. And this is also argc. So we can just do this as another argc, right? These are just local variables. All right. And then we can see this function does string length of the first argument and compares it to this value. And otherwise, it's going to tell us the flag is incorrect. So we can kind of look at this and understand that our flag length, the input flag is going to be hex 15 long, right? So this is our input length. And then this is just a for loop. It gave it local 44, but just for convention, I'm going to rename this I. Okay, and then we see this massive block, which looks very confusing. And this is because Ghidra has actually mistyped a couple of our variables. So what I want you guys to do is we look at this for loop and we can see it uses hex 15 as the condition, and it takes a local 38 plus that index as the location. Does anyone know if there's a data structure that will also take a base memory address and add an offset to access it? Just raise your hand if you know. Yes. Oh yeah, an array. Yeah. So let's go. So we can retype this as an array of bytes, and it's going to be hex 15 long, right? So the first one is local 38. So I'm going to right click on this and I'm going to hit retype. And I'm going to retype this to byte, and it's going to be hex 15 long. So as we can see already, this cleaned up our for loop massively, right? Now we can tell a lot more about what it's doing. It's taking our input and it's XORing against some constant. Another thing we can do is we can see this and 7 right here. This is a little hard to understand at first, but this is similar to like modulo if you were doing like an array modulo the size of it. So we can retype this one, local 40, as an array of 8 bytes. Okay, and then I'm going to rename this one as just data. And I'm going to rename this one as our output. Okay. So let's take a look at what the next line of this function is doing. This is doing a string compare with the output and our input. and it's comparing if they're equal. If it's equal, the flag is correct. Otherwise, it's going to say it's incorrect, right? So it's XORing, which is this little caret right here, are these constants with this data, and it's comparing the results of this whole computation to whatever we pass in. So this is pretty hard to understand at first. So Richie's going to take another look at how we can approach this with dynamic analysis. And a technique for dynamic analysis is we're going to actually try to set a breakpoint after it generates this output variable and take a look at what it actually is. Before we move over to Richard, does anyone have a specific question about the process I did or confused on a step? Yes. Data is going to be a byte of size 8. So you're going to right click and you're going to hit retype. This is a data type. The AN7 actually. That's just compiler shortcut. And then does anyone want to take a guess why it didn't assign our array elements one by one? Instead, it did it these block by block, right? It did these strange assembly instructions instead of like 32 move byte instructions. Does anyone have a guess why it might have done that? Or how that might have happened? So this is because of GCC. It's optimizing our program, right? Instead of moving each byte into our output variable one byte at a time, it notices we're moving, hey, we can move 8 bytes at once. So that's why it's doing it in chunks like this. All right, and that's all from me. So I'll go to Richard.
Thank you, Pete. All right, so that was static analysis. One of the differences between static analysis and dynamic analysis is that you have to do dynamic analysis on the machine that you're running it on. Or at least you need something on the machine that you're running on to like hook into GDB. But with static analysis, you can do this on a Mac, for example. That's what I'm doing here. Ghidra is Java, so it is cross-platform. It can run on any device. All right. Which one is the room like?
This is the room.
This is good. Okay, that's fine. I'm gonna need both hands for this. Yeah, this is GDB is a little bit more serious than Ghidra. But yeah, so if you guys haven't already, please open up GDB or open up your WSL or whatever VM you're using.
Open up your terminal.
Yeah, open up your terminal. Specifically, it needs to be a Linux terminal.
If you're on an M1 Mac, this is not going to work for you. The reason is
I lost the window.
Is different. On the setup slide, we have a section on how you can set up your own virtual machine to run these binaries that will not work on M1 Mac.
Sorry, I lost the window. It's like between these.
That's my saying.
I lost the window. How do I? Oh, there we go. All right, we're all good. So I'm gonna zoom in here. Hopefully you can see that a little bit better. Okay. All right, can I just get a confirmation on Zoom that you guys can see this?
Yes.
We're good, okay.
This is Zoom.
Oh, okay. Great, that's wonderful. So first step is to download the debugger file. So make sure you guys do that to your Linux machine or whatever you're running it on. Can I get a show of hands who has not done this yet? No, just a few? Okay, well, I'll give you guys one more minute. Yeah, so it's important that you have this file on whatever machine you're running GDB on. So All right, so once you guys have downloaded the file, the first thing we're going to do is make it executable. So on Linux system, on the Linux file system, there is this thing called the executable bit, which determines whether or not you can run the file. So in order to make it executable, you want to type chmod +x debugger. And this is going to make it so that you can run the file. So just hit enter once you do that. And now if you type ls-space-l, you'll see that it's green. And also that there is this X. There's 3 X's here, actually. So that means you can execute this file. All right. Yeah, so some first steps. The first thing I'd like to do is run file on debugger, just to see like what are we even dealing with here. So in this case, we are working with an executable, as you can see. There's a lot of information here, so if you haven't done this before, it might seem a little bit overwhelming. But the important part is that it says ELF, which means it is a Linux system executable, and that it is executable. It's not a different type of file. Yeah.
If you are inside WSL, if you want to get to your Windows file system, you're going to do cd/mnt/c. That's going to get you into your Windows file system. /mnt/c.
Okay. So, yeah. So you want to do something like that to get into your Windows. I'm not on Windows, so.
Today everybody, we had to be out here right at 7 o'clock today. So pay close attention here. I wish we could stick around and answer questions, but there's some class that's taking an exam here at 7 o'clock. So
all right.
Pay close attention. Raise your hand if you need help.
Yeah, I'll go through this expediently. So first thing I like to do is run file just to see that it is an executable. And then let's just run the file, see what it does. So immediately it says usage debugger flag. So let's try running this file with some sort of input. Now it says that flag is incorrect. So a couple of things to note here. First of all, to run it, you need the leading / in order to run the file. And then to pass in arguments on the command line, you just put a space and then you can pass in arguments that way. Okay, so now let's finally get into the dynamic analysis part and run GDB. So I have GDB configured with this thing called pwn_debug, which I find very helpful. But just for the purposes of this demonstration, I'm going to disable that. So this -nx here, you don't need to type it. So you guys can just type GDB debugger. All right. So once you guys have that, you should be launched into a GDB prompt. So you can tell it's GDB by this parentheses GDB. That's how you know. Let me just go back to the slides real quick. I did have some slides for this part. Just want to make sure I'm not missing anything. Yeah. Okay. Yeah, so a Ghidra cheat sheet and GDB cheat sheet are also on the slide. So if you guys want to download that, that's going to be handy. Okay. So let's get started with GDB. One of the reasons that this program is perhaps easier to solve with GDB is, as you can see in the Ghidra thing, where did that go? All right, I think that might have closed. In the Ghidra decompilation, let me just pull this up again, just so you can get some motivation for why we're even running GDB. This string comp, the condition for the flag being correct is this variable has to be 0, right? And that is 0 only when the argument is compared, only when the argument is the same as the output array. So that means that this program is passing in your arguments directly into a comparison with some unknown value. So what if we set a breakpoint here and figure out what this output value is? Then we could solve this challenge pretty easily. So why don't we do that? First thing I'll do is type start. So what start does is it stops right at the main function of the file. So it's just start. So that's what I typed here. And then it set a breakpoint and it's going to start it. Okay. There's a couple of settings. There's a couple of settings that I like. One of them is disassembly flavor intel. If you guys like reading AT&T syntax, you don't have to set this. And another one is disassemble next line. So you want to set this on. So these two options are pretty handy. Again, this is sort of optional, but it's nice to have. So why don't we take a look at what this main function is? So if you type disass, which is short for disassemble, it's the shortest prefix. It's the shortest prefix that like doesn't conflict with anything else. So disassemble, disassemble main. So we have a lot of stuff here. So you can just type enter to skip over that. Let me go back up. So I type disassemble main, and that gets you a disassembly. So if you look at this disassembly, it's exactly the same thing that we had back in Ghidra, in the Ghidra disassembly. It's just that you can also see it in GDB. So next thing I'm going to cover is breakpoint. So remember, we said earlier that we want to stop at the string compare, right? Because we have a string compare. It's getting a string compare just compares two strings and it returns 0 if they're the same. So we want to see what it's comparing it to. So why don't we set that comparison in here? Now, where do we set it? If you look through the disassembly and just search string and compare, you'll see that it's only called once. So we can just set it here. How do I search? So I'm using tmux right now. That's a bit beyond the scope of this demonstration, but no. If you're on iTerm, you can Control F also, which is pretty neat. Or Command F for Mac. And I think on Ubuntu, the default terminal, you can also Control F to search. There's another way to find this address, and that is in Ghidra. It tells you what the address is of this string compare. So if you look on the left here, this 004 something something, that's the hexadecimal value telling you what the address is. So I'll just copy it from here and then set a breakpoint. So to set a breakpoint, I'm going to do b break. OK. So all of these commands I'm going to show you have shortcuts, like smaller variants. That's why I type disass instead of disassemble. It's because it saves me some time. But I'll type the full one for today. So the star here, the star is actually kind of important. The star means that we should break at this exact address, not at a particular line. So if you omit the star, it will round to the nearest line of source code. Yeah, so just use the star if you're working with addresses. So we're going to set a breakpoint here. And if you remember when we ran this program earlier, it needs arguments from the command line. So how do we do that? You can do run space and then whatever your argument is. So let's just give it like A, B, C, D, E, F, G. OK, so I'm going to run this again. And then remember, we have a breakpoint now at the string compare. It's going to ask you if I want to restart. I'll click yes. The flag is incorrect. Why did it not hit the breakpoint? Anyone have any ideas? Yeah, are you raising? The string length? Yes, that is correct. So if you are looking closely at the binary, this string length is compared to 0x15. So if this is false, it's going to print out this flag is incorrect. So let's see what that is in decimal. So it's 21. So let's type 21 characters in here. But I don't really want to do that. So you can also use a subshell in the input itself. Actually, no, that's a little bit too complicated for today. I don't think we have enough time. So we're just going to type out 21 characters. Sorry. All right. 21. Sorry, exactly 21. That's 21, right? There's 5 E's. Yeah. All right. So now I did run with those arguments. If you guys can't see it. And now I hit the breakpoint. So now we can see what it's being compared to. As you can see, we're stopping at breakpoint 2. And that's 2 because I ran start earlier, and that set it to breakpoint. That set at breakpoint 1. To find out where your breakpoints are, you can do info breakpoints, or I space B for short. But info breakpoints, that tells you what the breakpoints are. So breakpoints are places in your program where GDB will stop at. To disable, you can delete breakpoints with delete 2 or disable 2. So disable is like a temporary delete, and then delete like totally gets rid of it. With disable, you can also enable the breakpoint later. So, okay, we're now at string compare. So we can see what the string compare is comparing our input to. So how do we do that? Well, on x86 Linux systems, there's something called calling conventions. So the arguments to this string compare function are passed through the RDI, RSI, RDX, RCX registers. So that's the order. And then I think R8, R9, R10. If you don't remember that, you can look on the cheat sheet where I have calling convention. That's the order. So let's print some of those registers. So to print registers, you type info register, and then the register you want to print. We can print all of them, but that's a lot of registers. I don't really care about all of them. I only care about the arguments. So the first 2 arguments are always an RDI, RSI. Okay. So now we've printed the arguments. You can see that the value is 7FFF, which usually if it starts with 7F, that means it's a stack value. We can print the stack register, which is RSP, and you can see that those are very close to each other. So that's how you know that it's most likely a pointer. So with a pointer, the obvious thing to ask is, what does it point to? Because with string compare, it's passing in 2 pointers and comparing the contents, right? So let's find out what these point to. So there's a command called x. I don't know what the full command is, but it's x/, and then, so I'm just going to type this and then explain. So x, it means print some memory values. And then 4 means print 4 values that are G wide. So G is 64 bits. You can also print W, which is 32 bits. And then X means print them in hexadecimal. So then I'm going to do $RDI, which prints it at, which will look at the memory at the RDI register. So RDI is, hopefully I'm explaining this well enough. RDI has this value, so it's going to see what's in memory at this location, at this address. So let's look. This looks like a lot of garbage, but let's try to print this in a different way. So what if we printed this with x/s? So s means print this value instead of as a hexadecimal, as a string. x/s RDI. Look at that. That's the flag. Thank you. So that's the flag. If we print RSI, you'll see that's what we inputted. A, B, C, D, E, F. So this is the flag for the challenge, actually. So at this point we've solved it. I'm gonna go talk a little bit more. We should wrap it up. Okay. All right. I'm not gonna talk anymore then. Yeah. Look at the cheat sheet. There's some other stuff about dereferencing, and then stepping through. But yeah, go try yourself. Start with, there's first RE challenge on the CTFD, and then a bunch of other CTF challenges as well. A couple more things. Again, this Saturday, we have fall CTF. So come out to that. Yes, go register. And then next Thursday, we'll have our OSINT meeting about how to professionally stalk people.
Give it up for Richard.
Thank you.